Hello friends, in today's session we are going to discuss about lines and angles with some examples from our daily life where we use these. We've been using lines and angles right from the beginning, where we started using standing, sleeping and slanting lines to write alphabets and draw figures, and then as we grew up we learnt a few terms related to lines and angles. Let's take a quick recap of those terms. Line segment. Line segment is a part of line with endpoints. Say for example, I draw this and where I mark these two points as endpoints and I name them A, B. Now this is a line with endpoints. It is called line segment. And then we've studied ray. Ray is a part of the line with only one endpoint. So if I draw this where I have one endpoint named A and it can be extended on this side as much as we want. So this is called a ray, and we represent a line segment by AB with a bar on the top of it. We represent a ray by saying AB, where we could have some point B over here and then it is extendable on that side. So we draw an arrow above AB indicating that this is a ray which can be extended on, which has an endpoint, one endpoint, and on the other side it can be extended. Then we have a line. We have something like this where we name any 2 points, but this can be extended on both the sides. So this is represented by AB with a double-sided arrow on this. And then we have studied about collinear points. So if we have 3 or more points that lie on the same line, we'll take an example. Supposing we have these 3 points or we have 4 points. Now these 3, there is no way that I can make a single line containing all these points. I can join any 2 points and make line, but I cannot put all the 4 points on the same line. So these are non-collinear points, but if I have points like these, 3 or 4 or more, and if I just draw a line and I can have all the points lying on the same line, they are called collinear points. And we've already talked about non-collinear points. If 3 or more points do not lie on the same line, then they are non-collinear points. The important thing to note here is we're talking about 3 or more. We're not talking about 2, because any 2 points will always fall on a line. Because if we just join these 2 points, we get a line. So we don't talk about 2 points, we talk about 3 or more points. If all of them lie on the same line, then they are collinear points. If they do not lie on the same line, then they are non-collinear points. Let's now take up some of the terms related to angles which have been studied in earlier classes. So first of all, what is an angle? What do we mean by an angle? An angle is formed when two rays originate from the same endpoint in same or different directions. Now supposing I fix this as an endpoint, and from this endpoint I draw a ray like this and I draw another ray like this. So now this is called the angle. So an angle is formed when two rays originate from the same end point. So this is the common end point. Let's name it A, and they move in either same or different direction. So if they move in the same direction, then we are saying one ray overlapping the other ray, and then the angle would be 0 degree. So there's still an angle formed between them, but then it will be 0 degree if we have the line on the in the same direction, if we have the rays in the same direction. Then vertex. Vertex is this common endpoint A that we just talked about. This is called vertex. Arms of the angle. So now these two rays, let's name them, give them some points over here. So these two rays, ray AB and ray AC, these are called the arms of the angle. Now acute angle. Acute angle is when this angle which is formed between the two rays is between 0 to 90 degrees. So we are saying less than 90 degree, and more 0 or more than 0 is called acute angle. Right angle is when the angle is exactly 90 degree. When the angle formed between the two rays is 90 degree, that is called right angle. Then any angle more than 90 but less than 180. So anything that we make here, this angle that gets formed, or this angle that gets formed, this is called obtuse angle. Then straight angle is 180 degrees. So if we are saying, if we name this common endpoint as A, then, and this as B, this as C, then if we see AB and AC are at 180 degree from each other, so we are saying they are making a straight angle. And then reflex angle is if we have this ray AB, and if we have angle more than 180 degree and less than 360 degree, say for example we have this AC which makes an angle more than 180 degree, this is called reflex angle. So we have acute angle, right angle, obtuse angle, straight angle, and reflex angle depending upon the value, the angle, the value of the angle formed between the two rays. Now complementary angles. Complementary angles are two angles that add up to 90 degree. So if I make an angle, say this is 15 degree, and I make another angle, say this is 75 degree. Now since these two angles add up to 90, 15 plus 75 makes it 90, so these two angles are complementary angles. And then we have another type which is supplementary angles, and supplementary angles are the angles which add up to 180 degree. So supposing we have an angle, we have one angle which is 30 degree, and we have another angle which is 150 degree. Now they are adding up to 180, so these are supplementary angles. So now let's see some real life examples where we use lines and angles. So first of all, when some kind of a tent is set up on the ground, then the poles are fixed at some angle. Now that what angle do we need depends upon the kind of tent that is being set up. Supposing we have this kind of a tent being set up, then we would have this angle at which the poles are fixed. But if we have a rectangular tent like this is the ground, either like this or like this, we have these poles at 90 degree to the ground. So the poles will be erected at some angle depending upon the shape of the tent that is required. Now we've commonly seen, supposing we're walking in the sun, we see that the shadow formed keeps on changing depending upon the angle of the light source. Now when we're walking in the sun is definitely the light source. So supposing the sun is here and you're walking here, then this angle at which the sun is will make the shadow. Now if the sun moves overhead, the shadow forms gets, as it moves from this angle to getting overhead, the shadow becomes smaller and smaller. So the length of that shadow will depend upon the angle of the light source. So this is not just case of sun. If you have a torch in your hand, if you're trying to make a shadow of some object, you can see that if you keep tilting the torch by some angle, the length of the shadow will keep on changing. Then we have refraction and reflection of light, which also depends upon the angle at which it is incident. So supposing we have glass of water and we have a pencil over here, we see that the pencil seems to be broken here, or it seems to be bent like this. So this refraction depends upon the angle at which this is tilt. So these are all the places where lines and angles are significantly used in practical life. We see that based on the angle changes, we see a change in the results. And when we design the buildings and other structures like bridges, etc., of course, depending upon what load is to be handled, the different materials and the different angles and things like that have to be considered. And of course, not just from a strength perspective, from a design perspective also, we need to take the angles and lines. And of course, there are many more examples like that from our real life.
Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.